In these videos, I'm going to look at some examples of problems involving two-sample t-tests, but this first example actually is a really important question in statistics. When you get to the end and you've done all these different tests and you have a situation, you have to decide which type of test are you using. Is it a one-sample t-test, a two-sample t-test, matched pairs, which is like having two samples, but because they match up, you do it with a one-sample procedures, looking at the differences. So on this problem, we're going to read these and identify, is this a single sample, a matched pairs, or two independent samples? Explain your choices. Okay. Now in these videos, I'm not going to read every word of the problems to you. You can pause them and read through them. Take your time. So do that. Read each of these. I say pause the video, read each of these, and try to answer the questions, and then I'm going to answer them. So if you look at part A, the key is, when it describes how he's going to collect the information here, how the researcher is going to collect information, it says that he uses each text segment to teach a separate group. There's two separate groups that are being compared. So it's two independent samples. Then on part B, when you look at this one, each child studies both topics, and then they're assessing each child twice. That's matched pairs. Okay, let's move on to an example, a numerical example of a two-sample t-test. So there's kind of two types of problems depending on the information you've been given when you actually use we're going to use the TI-84 to do the two-sample t-test. Either you have the actual data, which we will on some examples, or you have the summary data, which is what we have here. We have the means, the standard deviations, and the sample sizes. So again, read through the problem on your own there to get the background setting. Okay, you can pause it and take your time. But we're trying to figure out, and I don't know that I pronounced this right, malathion, I suppose, the name of this pesticide. Is there significant evidence at the 1% level that malathion reduces the mean number of larvae per stem? Okay. So we're doing a two-sample t-test to compare these two groups. So on our calculator, you can hit the stat button and go over to the test column, and we're going to use number 4, two-sample t-test. Okay. So you select that, and then you have the choice of either using data or stats, and here we have the summary stats instead of the actual data. If you have the data, you have to enter them into the lists first, but since we have the stats, I pick that option, and then it lists for me exactly these numbers here that I need to enter in. It sets them up. By default here, I hadn't used this calculator yet, so everything was zeros. You may have numbers in there, but you're going to change them to fit this problem. So, and it doesn't matter which group you do first, but I'm going in the order they were listed. So for X bar 1, the first mean, I put 3.47, and then 1.21 for the standard deviation, 13 for the sample size. And then for number 2 there, we have the second mean, 1.36, the other standard deviation, 0.52, and 14 for the sample size. You have to scroll on down because it doesn't all fit on the screen. The next thing you have to do is make the choice as to, is this a one-sided or two-sided test, and which direction does it go in. And again, our notes tell us to always choose no on this option to do the more complicated computation. Let the calculator compute a better standard deviation for the combined samples for you. But in this, you have to read the problem. Again, the advice is, if there's good reason to do a one-sided test, if it's implied in the problem to do that, do it. Otherwise, do the two-sided with the not equal to. But here it's asking, is there significant evidence at the 1% level that this stuff reduces the mean number of larvae? Okay, so we think that in the treatment group, the mean is actually going to be smaller. It's going to reduce the number. So we expect mu1 to be bigger than mu2, or mu2 to be less than mu1. So since it's set up in the calculator as mu1 first, we need mu1 to be greater than mu2. Just like it appears in our sample, we're trying to test whether or not, based on random sampling, that's significant evidence for the population. And you can hit either calculate or draw. If you do calculate, it'll just give you the numerical values that you need. If you do draw, it'll also draw the normal distribution and show you the shaded area, or the t-distribution and show you the shaded area. Again, the hypothesis that we're testing here, our null hypothesis, is always that there's no difference between the two groups, that the two means for the population are the same. And based on our sample here and the background, we think that mu1 is going to be greater than mu2 for the population. That's our alternative hypothesis. We compute the probability that we would have gotten a sample like this if that was the case, if the mu1 was equal to mu2. And our calculator, if we do calculate, gives us the t statistic if we need to report that, 5.8 something here. We could round it, 5.81. And the p-value, if you look on the end, there's the e negative 5. This is a really small number. This in scientific notation. It's in scientific notation. If we take it out of it, it would be 0.4 zeros and then 132 something. Okay. So it's very small, definitely less than 1%, less than 0.01. So we have good evidence to reject the null hypothesis. If mu1 was equal to mu2, this type of sample would have only happened this proportion of the times, which is tiny, so we have good evidence that h sub 0, the null hypothesis, was not true, which means we do have good evidence that there is significant evidence at the 1% level that malathion reduces the mean number of larvae per stem. And again, I apologize if I'm mispronouncing that word.